Yeah, that's it. Just wait for a few more minutes and we'll start. Thank you. Ross. We start 9:05 because it's a conflict rate. People would not see it. Oh, but we need something, the tapes or something like that. Oh, so it is.
So you'll take the puzzles on.
Yeah, on a whiteboard, yes. How about that? Is that okay?
We don't have a whiteboard, it's just
Yeah, this. But how about the.
how will you do the transactions?
Sorry?
How will you do the transactions? Pull for transaction ID on, because then you'll have to remember them every time. Because otherwise tear the flipboard in the transaction.
At the beginning, we have two transactions. At the very end, three of them, and doing it one by one.
But where will you
We will write them on whiteboard.
on each?
Yeah, everyone should write it down, and they will do it. That works. Okay, I think we can start now. If someone joins us later, they're welcome. Hi to all and welcome to the session, which is Building on Blockchain. I'm Arvin Cambery from Diplo Foundation and will be moderator of this session. First of all, I would like to point out that this is a session for the newcomers. This is the basics about the blockchain, and why we are doing this again as for a newcomer session is because a lot of people who are coming to EuroDiG are first comers. A lot of them are just to be introduced to many technologies we discuss, or many issues around technologies we discuss on this kind of forums. And to be honest, 15 years after the beginning of the internet governance, we still do have sessions on how internet works, how DNS works, so how the basic things works. So this is actually a repetition from the last year's session we had on the EuroDiG, explaining basics of things that can be built on the blockchain. For everyone who would like to discuss more, how can I say, more complex issues on blockchain related to governance, etc., I will invite you to join the session after the lunch in the garden hall, which we will discuss a bit more on other issues from blockchain. That session will be led by Jorn here. So if you're more aware of blockchain, I guess this might be a bit boring for you, but let's see. Since the name of this session is Building on Blockchain, we will actually like to focus here on two things that are actually working on blockchain right now, and so far, to be honest. One of them is a network of transactions, and the second one is smart contracts. So having that in mind, I would like to introduce my colleagues, panelists here today. From my left is Walid Al-Sakaf from ISOC. Walid is also a lecturer at the Södertörn University in Stockholm. Yeah, is that right? And he will give us a short introduction afterwards. Next to me on my right is Jorn Ervgud, blockchain and data protection consultant, working now also as a professor.
No,
so,
lecturer.
Lecturer, sorry, not a professor. So let me just explain how the session will go. First, we will have Walid explaining what are main features of blockchain. You probably heard this so far, immutability, transparency, and etc., but we will Walid to give us an introduction on that. After that, we will showcase actually how networks of transaction works. And of course, this will be done with your involvement. So you will be involved in this session as an audience. And we will try to actually send some of the currency between you guys here in the room. And in this case, in our case, the currency will be the chocolates. So we will prepare here chocolates, so you will guys send chocolates to each other just through our analog representation of blockchain. So that's how we're gonna showcase that. After that, we will have a presentation from Jorn on smart contracts. This is another thing which is quite vivid on blockchain, working fine and there. Smart contracts would be interesting for both, particularly interesting for people with both technical and legal background. I guess some of you had that also. Following that, we will have a round of Q&A, because this is an educational session. We will try to put the Q&A as much as possible, so you guys can ask whatever. Without further ado, I would like to start with this session, because I think we might fit everything in 80 minutes we have. So let's start. Walid, please go ahead.
Okay, thank you, Arvin. First of all, let me say that I was hooked to the idea of looking into blockchain, and particularly at the very outset, Bitcoin, simply because it resembles some of the main characteristics of how the internet evolved. I come from a computer engineering background, academically speaking, and so I witnessed the evolution of the internet from the very beginning. And so I felt like nostalgic to the early days when the internet first emerged. So it made me wonder whether the same direction will be taken in the case of blockchain, to some degree, I see very similar, quite many similarities. But let me start with some very broad notions. The internet. We are at an internet event today. And so the internet's main characteristics are very clear to many, which is decentralization. So there's really no central authority in control. No one can say, okay, I'll shut down the internet today, or looks into all the traffic going on through the internet. That's one thing. Another thing is that it's transparent in a way that the routing mechanism, the TCP/IP protocol, everything is open source. So you can actually understand how it works seamlessly across borders and throughout many different channels. And thirdly, it is secure. It's secure in the sense that you expect that packets will be delivered. You know that if you send an email, when everything goes right, then the email would arrive. There are other things like malware, etc. These are not a part of the framework of how the internet works. But the way it functions makes it prone, let's say, immune from, let's say, being error. It has a way for checking errors, for example, and all sorts of things that make it rather reliable. And so the only issue with the internet is that it allowed us to communicate. So it allowed me to send anyone email across the world or any form of message across the world. But the problem with that is that if you send multiple emails on multiple communications, then you are duplicating the same content. So it allows you to copy and paste and replicate, etc. So it's one way of communicating. It works good, but it's not possible to use the internet to send value. And so it took a long way until 2009 when a guy or a group called Satoshi Nakamoto came about and said, okay, it's about time that we use the internet not only to communicate, but also to exchange value. In the sense that you can now, if you have a particular thing of value, like in this case, Bitcoins, you can use the internet to move Bitcoins virtually from one position to the other. In this case, unlike the way in which you communicate and send data, you actually remove the data from your side, and it suddenly appears at the end, meaning that ownership of the data changes. And so this is revolutionary. It means that you no longer need banks, you no longer need central authorities. But the way you think of it is that the main idea behind blockchain, Bitcoin in particular, was that they wanted to eliminate the need for a third party. It has to be a peer-to-peer cash system. That's what the white paper was called. And so it meant that you need to be decentralized, you need to be, of course, secure, and you need to ensure that there is no way for manipulating or trying to change data. And so what happens that instead of having the ledger, which is often used as the form of explaining what blockchain is, a ledger of accounts saying that this person sent this much money to this person at a bank or a third party, this ledger will be distributed and available across the world throughout all the nodes that are connected to the system. So it means that if someone tries to manipulate the ledger, that would be caught easily, because the copy of the ledger that is securely kept in every single computer will be the same, and so there will be a problem because one of them had been illegally violated the rules and tried to breach the consensus within this group. So that meant that it had to be a very strong way of having consensus. You had to be decentralized. You had to be what we call immutable, meaning that no one can change the record without consensus. And so these are what made Bitcoin rather the disruptive technology that we know of today. And basically, blockchain as an idea emerged from the architecture of how Bitcoin operated. So you need to give credit where credit is due and explain that blockchain had become like the notion, the buzzword used to describe how Bitcoin came about and made it possible to arrive to consensus without having a central authority. I know that we have limited time to discuss, but one of the main and important characteristics of any form of peer-to-peer networking, or let's say payment system, is to arrive to consensus without a third party, and that's one of the objectives of the training exercise. How on Earth can you arrive to consensus if you all have the same authority? And so the game that we will demonstrate today will help you understand how it is possible to do that and why this new idea is revolutionary in many ways. And I think that we'll have a Q&A part later to discuss more. Thank you.
So thank you, Walid. And let's start with this. Game. First, what we'll showcase is a network of transactions. So I will actually need to stand up. Go there, and I would ask for 8 of you guys who would like to volunteer to be a part of our network. Can I see hands? Okay.
Come on, don't be shy.
Don't be shy, don't be shy. Whoa.
You get chocolates as well.
Yes, yes, yes. Here you go. Here you go. Here you go. Oops. Here you go.
And Arvind, there's one back there as well.
Yes, of course. That's about it. Here you go. All right.
You could be anywhere on the net.
Where is, oh, sorry. Thanks. So I bet you all heard, this is for remote participants, to repeat. You heard about hashing, and hashing is really something which is related to the blockchains after all. So basically, this is the main feature of hashing, is to have a number to combine a large data into a smaller number. But even if something even slightly changed in this data, this number would be at the end completely different. For example, you see this slide. Text is different. Only difference is this G. As you can see, here is a small case, here is an uppercase G, producing a totally different hash. So that's the main purpose of hashing. Hashes are used heavily in a blockchain, and we'll try to actually mimic a bit simpler hashing today, but we'll try to mimic the hash. Can I have another second slide, please? The next one. No, the previous one. Okay. So this is the transactions, and this is how we're gonna start doing actual network transactions right now. So we will skip the Genesis block in which all of you guys actually had the chocolates, and I will just deliver it to you. So let me see who was the minus. It's you? Don't eat the chocolate still. You need to send them to someone. It's 6, 8, 10 for you. Okay. Let's distribute this around. It needs 20. 10 for you, 10 for you. Is it? 3, 5, and 5. Oh. 10 for you. Yeah, distribution is hard. Was there anything? Oh, here we go. 3, 6, 9, 10. This is your initial loot, yeah. So, yeah. 3, 6, 9, 10. Of course, you can spend your currency. He can eat it, you know. So whether he will, but he will not have anything to transact with, you know. So, 5, 10. Yes. Anyone else? Did I miss one? Oh, sorry. Yes, 3, 6, 9, 10. And the number 4, yeah? You're a number 4. 3, 6, 9, 10. Anyone else? No, that's it. Yeah, here you go. Thank you. Just a friend, yeah. Sorry, go ahead. I can't, yeah, please.
I really think that you did not do it just that he was your friend. I'm really interested about that idea of fitting in
No,
the whole picture.
he's not going to be in the game. He just wanted to eat it because
That's
he's
clear
alone
now.
sugar
Thank
now.
you.
So that's it, yeah. He's not, he's not in the game. He's just like had a droppage of sugar in blood, so he needed chocolate. That's it. So he's out of the game. He doesn't have a number. First of all, why you guys get a number? This is a representation of, let's say, a wallet. You heard about that. This is your personal number on which you can receive and send any kind of currency or any kind of, in this case, chocolates. But this is your personal identifier in these networks. So all of you guys have a personal number. So let's see how the actual transaction works. First of all, transaction needs to have a timestamp. It needs to have a number of sender, identifier of a sender, amount of units sent, identifier of a receiver, and at the end, there is a fee. All networks actually works with the fees. All transaction works with the fees. We heard that there is no intermediaries to pick up the fees in this, but there are miners, or people who actually work on transaction, validate them, and as a reward, they get the fees from the transaction. And of course, as an additional reward, they gain a newly minted or newly created currency or amount of units. So for this game, as you heard, valid at the beginning, the most important feature of blockchain is actual transparency. So we will actually call out our miners to try to help us. Can Lara, can you be one miner? Who's there? Yana? What? Okay, Michael. But Michael, we will need you a bit later. Let's have 2 miners first. Guys, you're going to be miners, and actually, they have guns there. Oh yeah. Yes, that's really important, yeah. And now, let's make transactions. Who will send, let's take 3 transactions from you guys with chocolates and sending somewhere else. Let's do it, come on. Can you announce your transactions? Anyone? Okay, go ahead. You see? And what is that fee? What is the fee? You will need to have some kind of fee that your transaction is going at. 1 chocolate. Okay. So let's write that down. Let's have this format, write it down. First of all, we need a timestamp, so we'll look at the watch, and it says 11:20. So let's use just minutes. Let's say 20. 20. Okay. Sender, your identified number is 6. Sending 5 chocolates, you said. 5. To number 3. Yeah, is that right? With a fee of 1 chocolate. Okay. So this is 1 transaction. Let's have another one. Let's have 3 transactions. Go ahead, please.
Okay, I will send 3 chocolates to number 4.
3 chocolates for number 4?
Yeah.
And what's your fee? What fee?
Yeah. I don't understand the idea of this fee. Can you explain it again?
A fee?
Yeah.
The fee?
And why I decide about it? Do I decide about it?
Yes, you decide about it. We will show a bit later why is this important, but just
Yeah.
decide on it.
But what should I say? I mean, okay, 2.
2. Okay. That's the amount you need to go.
Okay.
No, just a second, just a second. You're writing it down? Already? Okay, but now it's 21, so it's not the same timestamp. Yeah, 21 minutes. Number...
What was the number of the lady? 1.
Your identified number is number 4. Yes.
1.
Sorry, 1. With a fee of 2. Let's have another one. Let's have another. Go ahead, please. Sorry, I couldn't hear you. Sorry.
I will send 3 chocolates to number 3 with a fee of 1 chocolate.
Please, your...
My number is 8.
It's 22 now, timestamp. Your number is 8?
8. 1.
With a fee of 1. Okay. So those are 3 transactions right now, and let's try our miners to work on it. How are they going to work on it, and what's important? Well, from this number we will have hash, but let's first answer your question, why we had the fees and why is this important? I will now, for example, fees actually works as an incentive to the network, to the miners. Because there is no central institution to take the part of the transaction, miners took the part of the transaction. And the fee actually incentivized them to be miners. Once they create a block, they will also get a newly created chocolate, but will also get your fees, or fees from the transactions. So that's an incentive for them to actually be and verify this network and to work on it, to work on your transaction going through. So if we now ask miners, what will be the first transaction they will work? What will be the first transaction you will work? With the biggest fee, of course. So that's the idea. So they will first start to work at this transaction. That's the basic incentive around the network. And it actually explains how the network will work after everything is mined. You heard about miners and mining new currencies, but at the end, the currencies might stop. Like Bitcoin has 21 million Bitcoins, and when all are mined, what next? What is the incentive for networks to work on it? So incentives are in fees. So this is the basic idea. So unfortunately, I think that, well, number one we'll get first. So
Just to add a connection to the Bitcoin
ahead,
network,
please.
you recall in the peak of end of 2017, there was a huge scalability problem in Bitcoin. It took many hours to get through the transactions. And the reason for that is that people had to increase their fees, and it came up to $22 per transactions. So it was quite heavy. That is a reason why fees play a role to get transactions faster.
Yes. Thanks, Walid. Just to have this prepared. I didn't know you were going to be so short. So. And now we go to the hashing, the previous one we saw. We'll use now a really kind of a representation of what the hash really is, and we will try with an adding hash. What that basically means is we will add plus here and summarize it to be one number. According to that number, we will choose the question, or how can I say, do you guys have pens? It's okay? Yes. Please sum it up and make it a hash out of it. How you make it hash? You just like plus here. Also, you have the plus, isn't it? That's it. So just come up with that number. What is it? No. 2 plus 1 plus 1 plus 3 plus 4 plus... So it's, what, 14? And reduce it to one number, single digit number. It's 5. Okay. 14, 1 plus 5 is also 5, so we need to get a number. So what's actually, previous slide. Can you? Can you have a previous slide? Is it? Maybe she's not so good at math. Let's see. 2 plus 1 is 3, 4, 7, 11, 13. Yes. This is not done by people, but actually graphic cards, which are way better in math. That's why I need it. Okay, so you guys, first we're going to do a second transaction. And why we needed a hash? Hash will actually, as you see, so we know that this comes up to 4. But when we see number 4, we don't know what was the input. So basically that's the representation. Okay, so go ahead, please.
Sorry. We came out at 13. What is the 4 for?
We wanted to have a hash,
you
a single
still
number,
do
yes.
okay,
So 1
sorry.
plus 3 is also
I
4.
lost that part, sorry.
Yeah,
Okay.
just hashing 5 till we get the simplest number.
Okay.
So why we needed that number is actually to have a question. You heard about that miners are working on a hard mathematical problem in order to, when they solve it, they are rewarded and the blocks is created. But what is this hard mathematical problem? It's actually about guessing. It's a sheer number of guessing the answer. This is not a quite, there is no way other to calculate except guessing it. So in order to have a most proper guess for you guys, we will have hash number 4 questions. We have this. And you will do a maze. Why maze? Let me explain this. It have to be done by tries and errors. So this is as closest representation of what the hash actually, how you solve the block of a header of a block. So guys, let me do a maze for you, a same maze for you. And before you start, let me just explain. The first one who actually did it will announce it, and another miner will actually check if that's all right. If it's okay, that it's propagated through the network, and that's the solution for this block. So let's start now.
Yeah. And I have here some music to play so that we can have exciting. No, it's drama.
Well, getting a chocolate's not easy. Getting a money is not easy. So working is actually what you... Go ahead, please.
It's just, if I understand it as understood it, okay.
Got it?
Please, Yana, check it if it's true.
Just wanted to understand in practice, they're trying combinatorics, combinations of numbers to come to the number 4.
Just a second, Zach. Yeah, go ahead.
No, just to understand it in practice, does this mean the thing that they're doing now is they're trying different combinations?
Exactly.
So it's combinatorics.
Yeah, exactly. Okay. It's just trying, is it this way, is it this way?
Yes. Okay.
Until you find a solution. Go ahead, please. Sorry, go ahead. Please use the microphone, if you can.
Sorry. You put it the time clocking, no? So they have to be also and see who is the different path or who is the fastest one?
Who is the fastest one? There is only one of us, yeah.
So that is what that thing is for, no? Because there are different minds working in the same time for the same thing?
Yes.
Okay.
All miners are working on the same block. Please join us, Vali. Don't do it from there.
No,
join
I mean,
us here if you...
Just saying that You decide, the miners decide on what block to form based on the transaction. So if they decide on the second transaction, they decide on that. That might well be the different transaction. It doesn't matter much. The moment that they announce that they have a block ready based on the transactions available, that is when their block is checked to verify that they got the right answer based on the transaction. So the maze solution, the maze now will have to be checked by the miners as well as the regular nodes if they are interested to verify that. And from that point onward, the whole, if the transaction that the other miner has been working on has been taken, it's no longer there. So they have to start all over again with a new transaction. So that's how the process goes.
Thanks, Walid. Go ahead. You had a question. Prior you get your chocolates because you are the receiver of this.
Yeah, but I still don't quite understand who in the first place generates these hashes that then they have to like...
The transactions. Let's have another second slide, please. You remember this was a transaction. So from this transaction, hash is created from this transaction. It has a unique timestamp, name of sender, and the receiver, etc. So it's derived from transaction. Understand?
It's
this
in
is
the
what
rules.
we write it down in this form.
Like, what agent or whatever creates this hash?
I can,
Go ahead, Bob.
I mean, basically, the rules of the whole blockchain applies that every miner has to create it in such a way. It's like the open source GitHub files of Bitcoin. The Bitcoin structure itself is based on how this standard format needs to be done. So every miner needs to apply the exact same rules. That's how it's.
Before we start the base, we actually do the hash, decide which one we want to, or decide first, do the hash, and then do this. It's the miner who does it, right? Yeah.
Exactly. It's always the miner.
But so the miner creates the hash, but then afterwards needs to like solve it back to like its original.
No, it has to solve something different completely. To show who's
Okay, so it's one miner who does the hashing, and then there's another one who has
No.
to solve it.
No. Everyone's...
I have the same path as he does, but I first went left, and the moment he said I'm done, I was like, oh, I'm done. You know, but we are doing the same thing, we see the same transaction, we see the same hash.
Go ahead, please.
One note.
Just one by one, please. Go ahead.
One note. We saw the transactions. I'm writing everything down too, but we just detached two things: 3 transactions plus the solving the puzzles. Now you connect them together.
Sorry?
These two are detached. 3 transactions with their kind of hashing and respective rewards per transaction, plus solving the puzzles. These two are detached right now. Now you connect them. How these two are connected, I'm asking.
Go ahead.
So I'm trying to see as a view of a miner, someone who wants to earn money, right? So I'm a miner, and I'm following different transactions, and I'm looking at the fees. I say, okay, I like this fee. I'll start with this one first. I do the hash, because we need to do the hash, because they're going to further explain. But then, in order to actually be the one who can verify the transaction, I need to solve the puzzle. And so does she, and so does many other people that also said, I want to do this one. So we all did the hash, and then we start competing who's going to be the first one to verify the transaction. And it doesn't have to be me, it can be her. This time I won, so she gives up and she turns to another transaction, probably a cheaper one, and then we start again. I don't know if that explains.
So you get all the fees for all the transactions?
I got the fees for
or
this
just for
transaction.
one?
For this one that I solved,
now I
right.
understand.
So
Thank
now
you.
we are moving to the next transaction, right?
Puzzle was for just all of them.
No,
Typically
it's just
it
for
was
one.
only
It's just for one. But let's do the transaction, actually. What was that? They need to be apart from the chocolates. 3? It's for you, yeah? Oh, here you go. You now have a bigger loot. This is a fee for the miners, yeah, for the miner who actually solved the transaction. And apart from this, here you go, Vlada. The miners, once they are done with the block, they also get the newly created units, you know. So that's the distribution of cryptocurrency via blockchain. They solve the block, they get rewarded from the initial number. Is that okay? And more
it's not clear.
Just a
see?
second, just a second, just a second. Go ahead, go ahead, go
Okay.
ahead. Go ahead. Go ahead, please.
Well, it appears that, well, maybe in this simple simulation
Yes.
that if you solve a puzzle for each transaction, then you open a block. But actually, each block contains a lot of transactions.
Exactly. In this, okay, we might miss this at the beginning. Our block have just one transaction. It's a really small block, you know. It's not 1 megabyte block, it's really 1 kilobyte block. So it's really, really small. It contains only one transaction, only one. So
And we have implied that the coin-based transaction, basically the one saying that he got the minted coins, is not included because it will complicate things.
Walid, will you come up and come on, please join us to show the Evo sad.
Now you actually begin building the blockchain. And so now you have actually, where's the pen? Can I? Here you go, down there. Yeah. So now you already started and you had the earlier blockchain, the blocks, which were the generous, etc. But now the newly created block is the Hello? Yeah. So the newly created block now is confirmed to have been won by number, the number of the block, hash? 4. And your number? 2. So we can say this is the number of for our demonstration purposes, we can say this is the block number that's been won. And so you can refer to the winner and the original, the hash of transaction. So in this case, you now have the one block, and this needs to be the same, not only here, for every single member of the network. They need to have this number in their blockchain. So 42 is the number of the block, and that's how you begin to build block after block. So that's one way in which you can think of it.
Stay there too. Be close to actually add if there is anything. So now for the second transaction, we will actually increase the number of miners. Michael, you volunteered? Come on, please go ahead. Yeah, please go ahead. Can you write down those blocks? Okay, please. The second one is not only, so just the first one. Yeah, this one is done. Yeah. Sorry, yeah, I will do it for you. Okay, thanks. So let's just mimic the first one. It was 2, 0, yeah, 6, 5, 3, 1. Here you go. And we will trust Lada, who said the first transaction, hash of first transaction is 8. And we left with the second one, 22, 8, 3, 3, 1. And the hash of that is 1. Thanks very much. Who was that helper? Thank you. Here's your pen. So, what you guys are going to do one transaction? Decide which one is going to be. First one, with the number 8. Go ahead, please.
We still don't understand why you gave him the additional ones from the back.
Yeah. Okay. Let's say. Well, the networks. No. Well, you probably heard that cryptocurrencies are not already mined. This we came in a case which are not already mined. This is also an incentive to miners to actually do their work. So when one block is created, in our case 4.2, the newly created currency is issued. For example, so far we have 70 million, let's say bitcoins. We have around 70 million bitcoins, and how they are put in a system. They are put in a system whenever there is a new block, the new block release a new number of units into the system. This is a reward for a block find. This is a reward for miners for the block find. So, for example, in Bitcoin now, the reward is 12.15, yeah, after the halving. 12.5 Bitcoins. So whenever someone creates a new block, 12.5 new Bitcoins are actually in the networks. They're created by themselves. They're created by creation of this block. So this is an incentive. This is a first major incentive for the miners. But when all cryptocurrency are mined, there is not going to be newly created one. So then miners will work only for fee. So that's why it has even fee and a newly created one. Is that explains a bit?
Yeah, it still sounds like magic, but...
Yeah, everything is algorithm and mathematics. It's magic. It's happening by themselves. Go ahead, Mike.
One more thing to bear in mind about especially the fee, the transaction fee, is that it's not just incentivizing the miners so that they can make money. It's also a way to incentivize the cost of the electricity, because it is a very energy intensive process, one of which, especially if miners are using, are heavily invested in mining crypto, at least Bitcoin, the cost can be in the thousands per month for their electricity costs. So think about it as try to make that connection to a more tangible, output as well in terms of the energy.
As a miner, so the response to you, how does it come that there is new currencies actually? When I mine gold, actually I dig the gold. Now in this case, I would get both the gold and be paid. And we dig more gold, and as we dig more gold, we get more gold. At some point, there is no more gold that we can dig. But we still mine because we have to do the mazes and stuff, but there is no more gold we can take, and we just take the transactions. But as long as there is more gold to mine, we get both the gold and transactions. It's a little bit weird system, but that's how it goes.
Yeah, it is a magic called math. Go ahead, please.
I have another question regarding to solving the maze, because you said before, well, if you look at the numbers, there's more than one solution that fits this scheme that we have now. Is it that if you solve them, there will only be one solution that fits like this particular format?
Yes, but let me
how
just...
do you...
This is the really simplified version. Let the previous slide, please, can you... This is how the actual hash look like. It's really hard to, it's almost impossible to kind of, I understand that in this plain level, you can have number one, maybe two or three times. But hash are quite complicated, actually. And as you can see here, if you change anything, any information, even smallest information in transaction, the entire hash will change. Why is this important? Because this hash is implemented in a block. So if someone tries to change anything in transaction, the hash will change and will not respond to the earliest blocks, meaning it's incorrect, meaning that someone is tempered it. Does that explain it a bit?
Yeah, but like the question is like if you need to solve it back in order to get the transaction right.
No, you don't solve it back.
No. No, you can't get information from hashback, to be honest. No, you can't. You know that this is always this. I can...
Hash is a sort of a stamp signature of this particular message.
But please, we're
We have only one signature. And you don't need to return it back to the message. It certifies that that's the message that you sent, but in a much simpler way.
But we are short on time, so let's try to kind of continue, and why we actually introduce Michael as a third miner, just to explain a bit. So you guys are going to work on a first transaction, is that right? And first transaction hash is number 8. So let me find where is that. Oh, okay.
By the way, I mean, Michael, you may want to use another transaction. That's up to you,
Let's all of the same. Well, with the increase of mining power, the difficulty of the maze, or let's say a problem which is solved, is actually increased. So they will now, because there's 3 of them, we'll have to do even more complex puzzle. So that, go ahead, please. Yes, yes. Same for, exactly. So we'll just try to simplify it here, you know, kind of to explain, but that's exactly the case. So that's why, guys, you get a bit harder puzzle this time, because you had a competition, so you need to work harder. Just a second. Okay. No, I mean, just let's have a same start. Are you all set? Okay, go. Come on, it's not so hard, guys. Is it? So you see, they actually try, you know? They go one way, and it's that end. Okay, let's go this way, and it's that end. That's how it's solved, by a try and error. You know, you can't have a mathematical formula how to solve it. But you need to brute force it, okay? You need to try it this way, this way, this way, until you find a solution. So it's, in analogy, is mostly, you know, maze, it's kind of... Well, oh, sorry. Okay, yeah, you're right. I tried maybe just because we are short on time, just to kind of help a bit. That's a scary music. Just please turn it down. It actually put the pressure on them. It doesn't need to be there. Oh, but I see Anna is close. Yeah, she is. Uh-huh.
Copyrighted.
Is it copyrighted, really? Well, we will need you for another block. Come on. Come on, come on. We will need you for another block. Turn off that music and come here. Okay, maybe this was too heavy for you guys? Yeah, you need improvement in graphic card. Go ahead, go ahead.
But this can happen with Bitcoin as well. It can be that there is no block for half an hour or so because miners are not finding a solution.
Exactly. So when that is the case, the algorithm, for example, in blockchain, in Bitcoin's blockchain, algorithm is saying that new block is going to be created in 10 minutes. Every 10 minutes is going to be a new block. So they had easier, puzzle, and they solve it in like 5 minutes. In the next block, as we saw, the algorithm will increase the complexity. You know, oh, yeah. You got it first? Yeah, I got it first, yes. But you guys need to check it, actually. You guys need to check it, is it true? You know, networks needs to check if this solution is truthful. Yeah. Congratulations to Anna. Yes, please check Vlad if that's the proper case. Yeah, okay. So let's see what was the transaction, and let's give people a chocolate. What was the transaction? Yeah, you're a nod. You can also verify everything as a nod. Yeah, it's transparent. That's why we're doing it in front of everyone. So. What was the transaction again? Let's see. Number 6. Who's number 6? Who? Who's there? Okay. You sent number 5. You said 5 chocolates to number 3, yeah? Is that right? I can't move there if not to kick the camera. 3, 5, 6. Okay. Who is number 3? Oh, that's for you. Okay. That was pretty generous, 5 chocolates, yeah. And a reward for the miner. Miner, this is a fee. And this is a newly created unit. Here we go. Yes, please, Valid.
So the transaction code, what was it? 8. So this was 8, and then the miners 81. So this is what they got. So the thing is that now the earlier one we saw Genesis, so we assumed that it was 0, 0, for example. So now what happens that this is 42 and this is 81. So the new block will actually be what is called a Merkle tree. So it actually needs to be a hash of 4281. And so that will be the one here. So maybe you can add them together. 9, 11. No, she is the winner. So is it 16 or? No, 9, 15. 1, 5? 1, 5, let's say, because multi digits. So it's not a hash of a hash, it's just hash one time. So in this way, we can tell how these are interrelated. So if this was removed for some reason, this number will change. So this is like a continuous, and the new one will be like that, so that the new one will depend on the hash of the earlier one and the ones before that, because they're all interconnected to each other. So that's how the new one is corrected. So it's 15. And the same block number will be on every single node on the network. And so that's the new block has been mined. Good. So shall we continue, or is that?
We're running a bit out of time because, of course, we're going to have another presentation. Sorry. Yes, we will not do the third one because of our time constraints. So. Well, we will have another presentation now on smart contracts. So thank you guys, thank you all for enjoying. Of course, you can eat your chocolates. And we will now have Jorn with another really important feature of blockchain, which is smart contracts. Please take care of it. Please listen to Jorn.
Hello. So, who has already heard about smart contracts? Okay. Can you say what a smart contract is? Can you say what a smart contract is?
Thank you. Hello everyone. Smart contract is online transaction when you can just sign any document online, and it's like blockchain works, it's hashed and kind of very secure and stuff like this. I have just general idea about smart contract. It's affordable, easy, and it's very secure. It's like based on the blockchain system and stuff like this. Maybe I'm not, but you're gonna explain it.
Okay, thank you. Actually, what you can see is that smart contracts is something that is not really very sharply defined. Everybody understands something else from the term smart contract. It has something to do with contracts. It has something to do with online. It has something to do with secure. It has something to do with automated. But the definitions vary. I want to bring it down to 3 concepts. One concept is that you do a contract not by legalese, but by something electronic, by a code. And the second one is that something is executed automatically. So it's not a contract that people manually execute, but that is executed by a computer. And the third thing is that it's on a blockchain, which is the element of trust. So going to the first one, The question is, can actually a code be a contract, a legal contract? And well, the question a bit more generally, can code be law? And of course, if we both want to do a contract and we both understand Esperanto, we can do it in Esperanto, of course. If we both understand Solidity, the smart contract programming language, we can do it in Solidity. No question about it. So the legal system says, of course, you can use any language you want, but it has to be understood by the parties. Then the question is this our contract? Or what is the contract? The contract is an abstract legal construct. This means that a contract is not the legalese, not the writing, the paper writing. You can go to a bakery and buy some bread, and you don't have a written contract, but it's still a legal contract. A written contract is just something that makes it easier to prove that you have a contract and what's in the contract. But what does it mean? It means when you have a written contract, it means that the legal contract can differ from the written contract. There is mandatory law that will always apply, and if you have a provision in your contract that's contrary to mandatory law, it will be invalid. It will not be executed. Also, if both parties agree and they can prove that they agree on something, but they put it incorrectly in the contract, it will still be as they agreed on. There's a Latin saying in contract law, falsa demonstratio non nocet, meaning even if you declared wrongly, it doesn't matter. The contract is agreed on what the parties have agreed on. So what does it mean for a coded contract? It means that the legal interpretation might differ from the execution of the code. So to answer the question, code can be law, but the contract can still be different than the execution of the code. As Lawrence Lessing said, code is law except when it isn't. Second thing, automatic execution of a contract. We all know vending machines. Vending machines are like automatic execution and even conclusion of contracts. You select something and then you get the chocolate. That's fine, but would you buy a diamond out of these vending machines, put in 1,000 euros and hope that the diamond will drop, and maybe it's stuck, maybe it's wrongly programmed and you won't get a diamond? Probably not. So the vending machine is in the sole control of one party. You cannot see the code, and the party can always exchange the code to something else. You cannot trust a vending machine. Of course, for some chocolate you don't care. It's not a huge risk, but for other transactions you do care. There is no secure logging, no proof. And that's the reason why I say if it's just automatically executed, I wouldn't call it a smart contract. But there are people who do. But this is the second aspect of automated execution. But you see, because this lack of security, there's something that provides this trust. And to give you another example, some years ago, Amazon was introducing the Kindle reader, and people had 1984 on the Kindle reader. And later on, Amazon had some legal issues, and they removed 1984, the book, from the Kindle reader of the customers. Which means there is some automated system, and they can just change the rules. And that's what we don't want. That's the reason why we use blockchain there, because it's immutable. It means you have a ledger that cannot be changed just by one party. And what are smart contracts in the programming sense? It's a programmable blockchain. So when we got the chocolate game, we had specific rules. Like when you do a transaction, the person who is receiving the transaction cannot get more chocolate than the person who is sending the transaction. Of course, otherwise you create money by it. Those are some kind of basic rules. And you can have more complicated, more sophisticated rules and put it into your own coding. And you don't have to create a special blockchain for it, but you can just use a programmable blockchain like Ethereum, for example. So in a way, with a blockchain that's fixed, it's like a law, in a blockchain where you can define your own rules concerning, of course, only your universe, it's like a contract where you also can define your own rules. So this is the blockchain inside of smart contracts. It's where you can define any kind of transaction rules within a blockchain setting. The advantage of a smart contract on a blockchain is that it's stored on a blockchain, it's executed on a blockchain, it's transparent, and it's mainly secured against manipulation. So you can't just say, well, one party changes it. If there is a possibility to change it, it has to be in the contract before, and you can't just include it later on. So the rules are there and the rules are kept. Then smart contracts can act on cryptocurrency. Well, our vending machine, they can act on money. You can insert money, it can accept money, it can keep money, it can give you back some money. So the vending machine has the power on some cash. The smart contracts on a blockchain, they have the power to act on the cryptocurrency and also, of course, on the ledger. So this is their domain. And if you have a smart contract that cannot act on any currency, then of course the value is largely reduced, because then the smart contract just states something but cannot execute it. So smart contracts are small scripts on a blockchain that can be legal contracts. But even if they are, it doesn't mean that one smart contract is one legal contract. A smart contract can be used to do a series of legal contracts. And also the creator of the smart contract is not necessarily a party of the legal contract. So there is a connection. Smart contracts can have something to do with legal contracts. They don't have to, but it's not one-to-one. To give you one example, let's say we have a seller who has a bicycle and wants to sell this bicycle. And of course, we want to sell it via a smart contract, like an eBay implemented as a smart contract. So we have a blockchain, and we have somebody who programmed a smart contract developer. And the smart contract developer puts the smart contract there, and the seller sends a message to the smart contract. I want to sell a bike for 4 Ether, or whatever currency there is, a description of the bike, and of course in the contract it says, well, there is no buyer yet, it's not paid and it's not delivered. Then, of course, there is somebody interested, looking for a bicycle, and he sees the offer and say, well, I want this bicycle. What he does is he sends an acceptance, so there's a contract made, and he already sent the money. But the money is stored on the smart contract, so it's not directly sent to the seller, but the smart contract keeps track of it, and if the seller does not send the bicycle, the buyer can get his money back. Then, of course, there's a delivery. The seller calls the post office, and the post office will bring the bicycle to the buyer. And the post will send a delivery confirmation to the smart contract, and with this delivery confirmation, the smart contract will transfer the money to the seller. Well, why did I use the Russian post? To illustrate two things. One thing is that the Russian post says that you want to do the tracking via blockchain. And the second thing is, of course, this smart contract lets you gain some trust. But still, you have to trust in somebody. You have to trust in the post that the confirmation is correct. And of course, you have to trust that there is a bicycle that works in the box that the post is giving to you, because the post will not confirm that you received a bicycle. The post will just confirm that you received a paper box, a card box. So what are the impacts of smart contracts? Where are they used? Yes, please.
Sorry, to the previous part of the contract. So the smart contract has another contract with the post office because they have to ensure that that was a bike which he sent, or the seller has to take the money back if that thing wasn't a bike.
Well, the post office is just what we call an oracle. So the post office is just sending, giving some information to the smart contract on the blockchain.
So it's a part of the smart contract?
Yes.
There is a line for the post office to the
Exactly.
smart contract? So assure that what was being sold was a bike?
No.
Because
no,
the problem is I order a bike and it comes a raccoon, and what I'm supposed to do with a raccoon instead of a bike?
Well, this is exactly part of the problem, that you can have more insurance, more security, but you will not have complete security. And even if the post confirms that it's a bicycle, it doesn't mean that it has to be a working bicycle. Maybe it's defective. So you always have some issues that remain.
So I cannot send it back because the money is already being sent to the one who sold it.
Well,
so I'm getting stuck with a bike and it doesn't function, or it's not even a bike.
Sure, that's a problem when you buy something from somebody remotely. It will not solve all problems. It
So
will
you don't,
solve
we don't have any insurance of what happened if this transaction is real, that means.
You have some additional insurance that you will receive something by the post office. Yeah.
Just to illustrate, this example is not maybe the best in terms of understanding how smart contracts natively work, but they have the combination of physical material with crypto material. But the ambition of Satoshi Nakamoto and you know, Laterik and everyone within the cryptocurrency is that we actually need to communicate exclusively in this ecosystem. And some way of thinking of smart contracts is multi-sig in Bitcoin. Multi-sig in Bitcoin is basically a smart contract because Bitcoin has its own language. It's called Bitcoin script. And it allows only if a smart contract can be something like an address that you send to, and this address has information saying only release this amount if two people sign the transaction. So in this case, it's exclusively in this ecosystem. It means that two individuals who have wallets sign the transaction, and then it's sent to that common smart contract, and then it is released to a third wallet. In this case, you actually have no outside interference. It's purely in the ecosystem. But realistically, and I like the fact that he mentioned the problems with this, that you step beyond the blockchain world and go back to the original human error-prone world. And that's why it's not complete.
Yep. I know that through transaction, I will use the smart contract. Sorry, I know that through real transaction, might use the smart contract, but I wouldn't use it for this transaction, actually. Because you are not ensuring me what I'm getting anyway.
No, well, if you buy something at eBay, it's the same thing. But you have eBay that insures, or PayPal that insures you some protection, but it's not full protection. And I agree, of course, Walid said, if the transaction is purely on the blockchain, if it's about some right you purchase, for example, or if it's about some thing that is noted on the ledger, then you can have complete insurance, security. But of course, always, if you touch the real world, you have real actors, and you need to trust somebody again.
Can I ask?
Yeah.
Thank you very much. It was very interesting, but still I have question related to the, you said that you can change the smart contract if it's written in the contract.
Okay.
And how it's possible, because when we have proof of work, like I confirm that I get the thing, and then this is hashed, and this is kind of very secured, and how it's possible to change it, and what are the...
Well, okay. I got still some slides with some problems, but I can answer this question right away. It is not possible to change a smart contract, but of course the smart contract can have some provisions that you can have a new smart contract that's connected to the old one, and will kind of, the transactions will be deviated to the new one. So you can have a provision in the smart contract. Pardon?
This is a new contract. This is not the change of the...
No, the original information will stay, but you can have a built-in switch into the smart contract that you can, with the proper authority that is defined in the smart contract, add a new provision to the smart contract.
So what kind of change would be? Can you just any example of it?
Well, it's any kind of update of the rules, and this is one very important aspect. Even the best programmer cannot produce a smart contract that's perfect. And even if the smart contract would be perfect, the outside world changes, and you might need to adapt the smart contract. And if you need to do that, then the question is, how do you do it? If you give this power to some central authority, all the value of your smart contract is gone, because then you again have a central authority that will decide. So this kind of governance needs to be done in a decentralized way, like the mining, like the blockchain is done in a decentralized way, so you can be sure that this power, when needed, is not abused.
Can I ask, here? Yeah. So, example was pretty interesting. What I got it interesting was the role of an oracle. So, the whole point, well, correct me if I'm making a mistake, but the whole point of an oracle is to stabilize the ecosystem in terms of trust, because what Post is doing, it's offline, it's doing an operation in the real world, it's confirming that it got the bike and confirming that it delivered the bike. Mm-hmm. So is this the role that oracles do?
Yes, the oracles take some
the special term, kind of.
Take some outside information to the blockchain. Because
Got
the blockchain
it.
has no eyes and ears. Let me give you some example. One example, where smart contracts are used, initial coin offerings, and this is some kind of internal example, meaning you don't have to trust somebody, but the transaction is completely on the blockchain. And this is the way that most startups in the blockchain domain are currently financed, and there are billions being transferred this way. Then you got, of course, the Bitcoin transactions that disintermediate banks. So you can make a transaction, you don't need a bank in between. And we got, with the share economy, we have a lot of intermediaries, new intermediaries. They don't provide a service, but just the connection between the provider and the consumer of a service. And all those intermediaries could be potentially, there's a large discussion whether it will really happen or not, removed by smart contracts, because smart contracts are acting as an intermediary between parties, but as a peer-to-peer intermediary. But of course, there are open questions. There are open questions concerning regulation, concerning governance, as I said. Let me just finish this slide, and then maybe you can get a micro already. The governance of autonomous platforms, dispute resolution, what happens if we don't agree? If you say the bike is defective and somebody else says, no, it is okay. It attracts criminal business because criminals need trust. They can't go to court because another criminal didn't deliver. So they need something that provides trust to them. And that's the reason why it's attractive to criminals. And there's an issue of privacy. Data is public on the blockchain. And there are the issues that we already discussed, like fees, energy consumption, and scalability. Your question, please.
Yes, thank you. So I have a question regarding identification. And for example, with the bicycle example, how do I, as the customer or the buyer, verify that I received this bicycle? I need then to identify myself in some way towards the smart contract and the blockchain. And I wonder, is that done? If it's not, is it something that is needed? Because there is a big debate about blockchain being, well, very transparent and anonymous. So I'd like if you could just say a few words about identification and the need for it, please.
Well, there are two levels. One level is identification on the blockchain itself. It is usually done via private keys. So to be the owner of an account, the account has a public key. So this public key can be used to send money to crypto money to it, or to do a transaction with it. And if you want to authentify yourself that you're the owner of the of an account and you can send cryptocurrencies from that account to somebody else, you use your private key that corresponds to the public key. And the private key needs to be private, and you sign the transaction with it, and with the public key you can verify that the transaction has been signed with the private key. Of course, this kind of private key has a lot of risks, because if you lose it, you can't prove anything. If somebody gets hold of it, you're in trouble as well.
So there's no way to identify yourselves towards the key that you own?
This is yes. Well, this is the identification of on the blockchain. Then, if you go to cryptocurrencies, we have a lot of discussion about KYC, AML, all the anti-money laundering thing. Then we don't want just to have a crypto authentication of somebody holding an account, but we want to have the personal identification. And then there is, of course, debate: how should this be done? And what's the role? What is the role of governments, of banks, of intermediaries who verify the identity?
Just a remark, sorry, it's 5 more minutes. We only have 5 more minutes for this session.
Yeah, but we can continue with discussion, I think. Yeah, sure.
So may I ask something, because I'm not completely, clear about what you just explained. doesn't exist real money. You are not, I am not, I have a key, I'm holder of a key, which I'm part of this, of these transactions. So I'm transferring you what, actually? What is my currency?
Cryptocurrency on this blockchain.
So how I bought this currency? How got hold of this currency? This is what where I'm supposed to buy it or get it or...
You can buy it from somebody else who has...
So I have to work just with the mines, you know?
Not with miners, but I know you got this chocolate, you got this you got this cryptocurrency. So I say, well, will you sell me some of them? And then I give you some dollars or some euros for it.
But how? No, wait a second.
And this is an exchange.
This cannot be online because I have to give him real money afterward.
Yeah. But of course, there is an exchange where fiat currency, real money, is traded against cryptocurrency. Maybe we have a lot of other questions. Yeah.
Yeah. So the way that my friend does it, he does work in, he basically makes his entire living from cryptocurrency exchange. What he does is he actually connects with people. Let's say he has Bitcoin that he wants to sell. He connects with people who want to buy Bitcoin, and he literally, in this case, generally speaking, he meets with them in person. They give him a cash transaction, and then
physically gives him money.
They physically give him money. And then he then sends them, or whatever. He then sends them to their online wallet the amount of Bitcoin that they bought from him.
But this doesn't have to be the case.
Come on. I give him money and I didn't get anything back.
Well, you
got
Bitcoin.
Have to go home and do it when you can do it.
Well, let's take it like it is.
You got a question, please.
Okay, let's have a question.
Right, of course, thanks. On a slightly different element of this, considering that, as we've somewhat seen, the vast majority of people will not likely understand Bitcoin or cryptocurrencies in general, and will need to do it either through another middleman or just see it as something like eBay. How is this any different to eBay simply having an escrow accounts function for the vast majority of people?
May I just add for the previous explanation for this? Yes. Okay, so now when you have the fiat and crypto together, the only way you can get it is basically buy it for the dollars, etc. But you can gain crypto, you can actually work for crypto. You can give your services online being paid by Bitcoin or Ethereum or anything else in a different, sorry?
I'm a new client. I want to get this crypto and Bitcoins. But I know how to start it.
Right now there are three ways. You can mine them, as we saw it.
Yes.
You can buy them for a fiat money. When we say fiat means dollars, euros, etc. Or the third option is to be paid in crypto for the work online. For your salary, for example, your employee gives you 10 Bitcoins for your payday. So that's the three ways how you can actually acquire them right now. You can mine them, you can buy them on exchanges or everywhere else, or you can work for them and someone can send you as a instead of money.
Well, I might add something. It's really, it needs a lot of trust to get into this.
But basically, go ahead, Björn, you wanted to add something.
So, of course, you spend money for cryptocurrency, and you have no guarantee that cryptocurrency is worth anything. But if you think twice, do you have a guarantee with fiat currency? Is there a guarantee that €1 will buy you chocolate tomorrow? There's a high probability, but there is no guarantee.
There is inflation, but at least it will buy me something. Or there will not exist any money anymore, so try to find the solution.
But of course, this is part of the cryptocurrencies. The system will guarantee you that nobody can just create inflation. So it's not possible to create the double number of Bitcoins tomorrow. It won't happen. But the system does not guarantee you that anybody will give you anything for 1 Bitcoin tomorrow.
Can will it work? Well, I'll give a case. For example, you pay 10 euro for this crypto chocolate. Would it encourage you to pay 10 euros if you know that there is someone over there who will definitely 100% pay you back your 10 euros for this crypto chocolate? Will that be a solution?
No, wait a second, please. I buy this chocolate for
you pay 10 euro for this crypto chocolate. Well, imagine crypto chocolate.
Okay.
Well, there is a problem of trust. Well, why should you trust this crypto chocolate, right?
That exists somewhere. Okay.
Well, maybe existing, maybe someone is lying to you, but what if there would be someone X guy who would pay you back any time when you wish it for? If you deliver to him your crypto chocolate, he will pay back 10 euros.
No, there is no point for me to buy it because I don't have any interest. Then at least it would be 11. If I want.
That's another side.
Okay. Thank you. Thank you. We'll have to finish this up. Yep. The people are hungry and it's lunchtime, so so just one more notion.
Really interesting anyway.
Please, I invite you to follow the session in the garden after the lunch. It's going to be also on blockchain, but on governing things on blockchain.
Not directly after lunch,
but
it's
not
4:15.
Oh, you moved the slot?
No, we don't move it. Was there.
Oh, it's 4:15. Okay. Yes. So thank you very much once more, and
by the way,
have a great day.
I melted the chocolate, so they're not functioning anymore.